Hello everyone, and welcome to material for lecture 13 and lecture 14. In this lecture, we will talk about fired heaters and furnaces. So we start by looking at introduction to the fired heaters and what are different configurations or classifications of fired heaters. We will look at some of the simple models for fired heaters and different types of fuels involved and some basic fundamentals of fired heaters. And in the final part, we will talk about theoretical flame temperature and some other heat transfer considerations in fired heaters. So let's start by looking at introduction and classification. So fired heaters are very important to any process, and in most of the chemical plants, fired heaters are essential part of the process, and normally about 75% of the energy consumption of your whole process is actually due to the fired heaters. So fired heaters are used to supply heat to the process, and this heat is produced by burning of fuel. Okay, and the fired heaters or furnaces are very similar to boilers. There is a very small difference in terms of its application, but in terms of the design or the basic fundamentals are the same. So fired heaters are mostly used when you require a very high heat duty, as you can see around above 50 megawatt, or you need a very high temperature in the range of above 800 degrees centigrade, or you need a very high heat flux. It means that you want to have much more heat transfer per unit surface area, or you want to have a significant amount of heat transfer, but you want to keep the surface area minimum. So these are some of the basic factors or features that dictate that when we need when we require a furnace or a fired heater. Okay, so fired heaters can be classified based on different factors. For example, what are their function, what is the heating method, and by construction as well. So if we talk about functions, so for example, fire heaters are designed to produce heat to provide it to the process, and that can be direct application of heat to satisfy the heating requirement of the process, or fire heaters can be used to generate secondary type of hot utilities. For example, you can use fire heaters in boilers, or boilers are actually fire heaters, so you can use these fire heaters to generate steam, or you can use the flue gas from these fire heaters to provide heat to the process. And you can also use these fire heaters to heat oil, and then again this oil can be used as a hot utility. You can also use fire heaters as a reactor, for example. So instead of using steam or hot oil to heat your reactor, you can actually put the reactant system inside a fire heater if you require a very high heat, for example, and then you can provide heat to the reaction, and that is mostly obviously the case for endothermic reactions. Okay, you can also classify fired heaters based on the approach to heating. For example, you can have indirect heating or direct heating. You can also classify these fire heaters based on construction, what kind of, for example, what kind of shape you are being built, and what are the design parameters. Similarly, you can also classify based on type of the fuel and the type of the burners. So there are several other classifications as well, but the most three important classifications are function, approach to heating, and by construction. And we will look into detail of these in the coming slides. So now let's have a look at what are the indirect heating, for example, of indirect fire heaters. So indirect fire heaters are the systems in which the hot flame, for example, provide heat to an intermediate liquid, and that intermediate liquid can provide heat to our, for example, process fluid. So here you can see that here you have the burner, and it is called the firebox, and the flames are actually producing hot flue gas inside this red tube, and then you have this light blue color fluid that is taking heat from this red tube and then supplying this heat to the dark blue process fluid. Okay, the heat is not directly transferring from the hot burner, but it is actually going through the heating intermediate liquid, and that supplies the heat to the process fluid. Okay, and this is how it looks in reality. These for example, fire heaters are very common in fertilizer industry. For example, when I was working as a utility engineer in fertilizer group, it was very often we were dealing with these kind of fire heaters for the process. So some of the advantages of these kind of fire heaters, one of the advantages that it maintains a constant temperature over a long time, because if you see here, for example, here you have an intermediate fluid, and in case if your gas is cut and your flame, for example, goes away, then this intermediate liquid actually can retain the heat for a long period of time, and as such, it will not affect your process significantly. So we use this intermediate fluid with a very high heat capacity, so as such it can kind of keep the heat. The other advantage is that it is safe and reliable. Reliable, as I explained, that it can keep working. For example, even if you have a problem with your flame or with your burning of the fuel. And in terms of safe, in the sense because you are not directly heating your process fluid, and for example, if you have a process fluid that contains, for example, flammable gas or gas or a system that can cause fire, so in that case, because you are using an intermediate fluid, so then you don't have to worry about the fire in the process or in the system. Disadvantage of these kind of fire heaters is that it requires too long to start. For example, because again I said you are using a liquid that has very high heat capacity, so before you reach a desired temperature, you have to heat your system quite a bit, because you have to increase its temperature, for example, to the desired level, and it takes very long due to the high heat capacity. Also, you are using an intermediate liquid, so you have to make sure that those intermediate liquids are stable and they are not toxic, or they do not dissociate at high temperatures. So these are essentially indirect fire heaters. Now let's have a look at the other type, that is direct fire heaters. And direct fire heaters are used when you require a very large heat duty, okay, to the process, or it means that you want to transfer your heat to the fluid as efficiently as possible. And as you can imagine that when we were talking about indirect fire heaters, we had an intermediate fluid that was transferring heat from the fire tube to the process fluid. And if you remember from heat transfer, that the more mediums are involved in your heat transfer process, the more resistances you have. So the intermediate fluid was causing an additional resistance to the heat transfer. Uh, so because in the case of fire heaters, we do not have any intermediate fluid, the heat will be transferred directly from the fire tube to the process tube or process fluid. So as such, you will be able to have much higher heat transfer, and as such, you can attain higher heat duties. Okay. So there are two types of direct fire heaters. The first type is what we call immersion type, and actually it is based on the mechanism of conduction and convection. And in this case, that fire tube is actually immersed inside your process fluid, and as such, you are directly transferring heat from the fire tube to the process fluid. And then you have the second type, that is what we call radiation convection based direct fire heaters, in which the heat is being transferred from the fire tube to the process fluid by the mechanism of radiation and convection. Okay, so let's have a look at these. So here is the example of the immersion type fire heaters, and these are very common in, for example, oil refineries, where you want to keep your oil hot because these oils have very high viscosities, and as such they can cause significant fouling to the process equipment. Okay, so here if you see that you have this shell, and this shell contains the oil that you want to keep hot, and as such you are using this tube here that contains the flame and the flue gases, and this tube is providing heat to this oil here. And the reason we do that because we want to avoid fouling, as you can see here. So this is an example of a fired heater tube that is fouled significantly. And we want to avoid fouling because we want to maximize our heat transfer from the hot fluid to the process fluid. And these direct fire heaters are also very common in, for example, in boilers or for low scale steam generation. Okay, and so what normally how we use them, again, we have the fire tube or the firebox where the fuel is being burned with the air, and then you have these tubes that are immersed inside the process fluid that you want to heat, and in the shell you have the process fluid. Like for example, you want to preheat the boiler feed water, or you want to create low level saturated steam. Okay, so as such you are providing heat from this tube directly to the water, and as such you are producing low pressure steam. Okay, another view of same, for example, boiler system. So here you have the firebox, and here you can see clearly how the flame would be inside the tube. Okay, and then this tube, or you have several of these tubes, and these tubes are actually heating the fluid around these tubes in the shell. And here you have also a viewing window, and these viewing windows are very important because more experienced workers can actually look at the flame, or from the color of the flame they can check if the for example system has a lot of excess air, or the system is choked. It means that you don't have enough air. So by just looking at the flame they can adjust a perfect air to fuel ratio in these kind of systems. So these kind of fire heaters use the mechanisms of conduction and convection. Now let's look at the second type, where we use radiation and convection as heating mechanisms. So what you see here in this figure is what we call a box furnace. And here what you have a burner that is burning the fuel at the bottom of this furnace, and as such providing heat to the system. And then you have this uh, empty space around this at the bottom of this furnace, and that is what we call a radiant section, where the heat from this flame is being transferred to the tubes that are in the vicinity of the tube or the furnace wall by radiation mechanisms. And as the flue gases move from the bottom towards the stack, these flue gases are being cooled because the heat is being transferred to the tubes or the fluid in the tubes. And then after the radiant section, we have what we call a convective section, where the heat is being transferred now by the mechanisms of convection. And again, you have rows and rows of these tubes here that contain process fluid. So for example, here in this section, we have choke tubes where you provide heat to the process fluid, and after first part of convective section, you have fin tubes, and again, where you are using the flue gas, and you cool the flue gas by taking heat to the process fluid. Okay, and the reason we are using here fin tubes, because now the temperature of the flue gas is lower, so we want to have more efficient heat transfer, and as such we are using high surface area by using fin tubes here. And finally, the flue gas exit through the stack, and that's the point after which we cannot extract heat from these flue gases. Okay, so these kind of furnaces are very common in most of process plants For example, in one of the plant that I used to work in, they had a furnace that was almost like 3-story tall. So these furnaces are really, really big. As I said, that this radiant section is almost the size of a room, and then you have these convective and stack systems that are almost again the size of 2 stores. So in total, the size of this furnace is equivalent to a 3-store building. Okay. Um, so these kind of furnaces are used for when you need very high heat duty. Also, we can use these furnaces to reclaim some of the heat from the stack. Okay, and we will talk about it in the next parts of this lecture. For this kind of furnaces, fuel to air ratio is very important. And again, when we will look at theoretical flame temperature, we will talk about fuel to air ratio there as well. So the fuel to air ratio is an important factor in these kind of furnaces. So for example, if you have too much excess air, you might not be able to achieve the maximum flame temperature possible. But if you have not, if you do not have enough air, then you might be in a situation where you have incomplete combustion. Okay. So again, we will talk about this fuel to air ratio in the next parts of this lecture. So one of the biggest advantage of these direct fire heater is that they give you very high heat duties to the process. And in terms of the limitations of these furnaces is that because these furnaces are quite large in volume, so you do require a lot of space for these furnaces. Another thing is that because these furnaces involve direct flame, so you have to be careful. For example, when you use these furnaces, that nothing flammable is present around these furnaces because it can cause explosion to the process. Okay, so these are some of the limitations of direct fire heaters. So again, this is another view of this radiation and convection type um, furnace. So here again, you have the burner at the bottom of the furnace, but you can also have burners on the side of the furnace as well. And then essentially here on the top of these burners, you have the radiant section that is, as I said, is essentially an empty room with the tubes next to the wall of the furnace. And then you have the convective section where you have most of the tubes where you have the process fluid, and then the flue gas going towards the stack actually heat up this process fluid, and finally it leaves through the stack. Okay, and this is how they look like in operation. As you can see that all these burners are providing flame, and then these are the tubes, and these tubes are being heated by radiation mostly, and then you have the convective section on top of this. And here if you see that you have the viewing window, and as I explained previously that these viewing windows are very important because the experienced workers can actually adjust the air to fuel ratio by looking at the flame color or the flame nature. Okay, and here I have a very interesting video that I just want to show you. That this video is mainly talking about boilers, but as I said, boilers are another example of fire heater. So let's have a look at that. Here you have the forced air that actually is pumping the pulverized coal inside from the side of this furnace, and then the second stream of forced air actually is being preheated by the stack or by the flue gas that is coming out of the stack, and then this preheated air mixed with the pulverized coal is burned, and then you have the flame from that. And then you have the radiant section here. This all is empty space and radiant section where the heat is being transferred from the flame to the tubes via radiation. And then this flue gas is moving upwards. And now here you have the convective section where you have, as you can see, you have rows and rows of tube that contain the process fluid, and this flue gas, as it goes up, use the convective heat transfer, or you have a heat transfer or a heat exchanger between flue gas and the process fluid. Okay, and then the flue gas goes out from the stack, and before it goes out to the stack, you have to scrub it to remove all the pollutants from it, for example, NOx and SOx, so that you don't have any environmental issues. And you use part of this flue gas to heat up the air that you are going to use in the chamber. Okay, and again we will talk about this. What is the function of this preheating of air? Okay, so that is the part for the furnace. But if you have, for example, as I said, here you have a boiler. So here, instead of just using it to heat up a system, here they are using to heat up the water that is in the tubes, and then they are generating steam for the process. Okay, so that is all for this part of the lecture. Thank you for your time.